is an instructional video brought to you from the farthest reaches of space to appear now in front of you for your enjoyment today. And now, we introduce our host, Daniel Ambrose.
Orbits with Daniel Ambrose. An orbit is the path of an object that has been curved by the gravity of another object. For example, the Earth orbits the Sun. But it's not just the Earth that orbits the Sun. Oh no. You see, the Sun is part of our solar system. This means that there's an entire system of planets constantly revolving around the Sun. These planets all have a different orbit around the Sun. In order from closeness to the Sun, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All of these planets orbit the Sun at different speeds, and at different distances from the Sun. The reason they all orbit the Sun is because they are caught in the Sun's gravitational pull, but are moving fast enough to stop themselves from being pulled closer to the Sun. The Sun is just constantly pulling the planets closer to it, but they move in a sideways direction relative to the Sun's pull. This causes the Sun to have to pull them back down, but by then the planets are already in a different position. This means that they go round in a circle, attempting to go sideways, but constantly being pulled back down at the same time. This results in them just spinning around the Sun in rings. All the planets are orbiting the Sun at different speeds, because all the planets are different. All the planets are different sizes, which means that it takes more energy to move the bigger ones as they have more mass. This results in the smaller ones moving faster. Also, the proximity to the gravitational center, which in our solar system is the Sun, influences the speed these planets move at. The closer they are to the gravitational center, the more pull that affects them, and therefore the faster they move. But there is not just one orbital system. The solar system is merely the system of planets that revolve around the Sun. The planets themselves have their own orbital systems. Earth has a very small orbital system. It only has the Moon orbiting it. But some of the other planets, like Jupiter, have many, many more moons. Jupiter has nearly 70 known moons. But other things can orbit these gravitational centers. Things like rocks, asteroids, gases, and space debris. For example, Saturn's rings are a mixture of gases and space debris which are caught in Saturn's gravitational pull. Also, asteroids can be pulled into rings around large gravitational points. These are often called asteroid belts or asteroid fields. There are just two asteroid fields in our solar system. The asteroid belt, which resides in between Mars and Jupiter, and the Kuiper belt, which is much bigger than the asteroid belt and sits out past all of the planets. These belts consist of asteroids of varying sizes, from ones the size of a speck of dust to massive ones, hundreds of kilometers in diameter. These larger ones are usually called minor or dwarf planets. In space, astronauts don't walk along the ground like us. They float. This is because up there, the gravity is weaker. We call this microgravity. Micro for small, like a mouse, and gravity for, well, the gravity. Because the gravity is weak, objects float in space. This allows objects with huge masses to be moved easily. Because of this low gravity, astronauts don't have to use their muscles much, and this can lead to muscle degradation over even a small period of time. This is proven to be a massive problem for astronauts, which is why astronauts don't usually spend long periods of time in space. Also, with this muscle degradation, returning to Earth can be difficult, as they have to readapt to the high level of gravity. Comets are part of our solar system. When a comet passes close to the Sun, it begins to emit gas. This occurs because the solar energy heats up the nucleus of the comet. This nucleus is full of loose ice, dust, and small rock particles. When the comet emits the gas, it forms a visible atmosphere around the comet. This is called the coma. Sometimes this coma will stretch behind the comet, forming a tail of light. There are thousands of known comets, and possibly millions of other unknown comets. These comets have different orbital periods. Some take only several years to make a full orbit, while others can take several million years to complete an orbit. Shorter period comets are generally comets that take less than 200 years to complete an orbit. It is believed that the shorter period comets have originated from the Kuiper belt, or its surrounding areas. The longer period comets are thought to come from the Oort cloud, which is a massive cloud of ice bodies that starts at the outside of the Kuiper belt and is thought to extend to about halfway to the nearest star. Comet orbits are different to the orbit of a planet. Comets have elongated elliptical orbits. This means that for part of their orbit they come closer to the Sun, and the other part they go further away from the Sun. This is because their mass is such that when they come close to the Sun, they build up enough speed to propel themselves out further, and the further they go, the less speed they retain. So the Sun's gravity pulls them back in, and then the comet builds up more speed as it comes closer, and gets flung back out again, and as such the circle continues. A black hole is an area in space-time that's gravity prevents anything from coming back out of it. And I mean everything. Light, matter, atoms, and even small children can't get back out. Around the black hole is a point called the event horizon, which is the point that nothing can come back out from. If something goes past the event horizon, it will never come back. It's called a black hole because it absorbs all light, meaning no light is emitted or reflected from it, making it completely and purely black. It is possible to safely orbit a black hole. However, the object that is attempting to orbit this black hole would have to have such a massive speed so as to avoid being caught in the pull and falling in. Much is the same with any other orbit. However, orbits around a black hole can be erratic. If the speed is too low, the object will just spiral into the black hole. If the speed is too high, the object gets thrown out of orbit and ejected away. If an object is at an intermediate speed, it gets put into a complicated orbit pattern known as a Rosetta orbit. There is a speed in which an object can achieve a perfect or near-perfect orbit, but it is dependent on the black hole's pull and the mass of the object attempting to achieve orbit.